Okay, for our next problem, 7.27, we are given that AB equals BC equals 10 and that AC equals 12. Find the circumradius and the inradius of triangle ABC. So let's make that triangle. I think what we can do is whatever. We're just gonna make a polygon, and we are not going to call that EFG. We're going to call that A, B, and C. Now we know the measurements are that AB is 10, BC is 10, and AC is 12. We have a nice isosceles triangle, which means that these two angles are the same. Now it wants us to find the circumradius and the inradius. I think the easiest one to find would probably be the inradius. How do I know that? Because we developed a formula when we covered the inradius, or when we covered angle bisectors, which was that the area of ABC is the inradius, R, times the semiperimeter, S. Now, if I can find out what the area of ABC is and find out what the semiperimeter is, then we can solve for the inradius. And that should be easy. I can immediately tell that I can find the semiperimeter because we have all the sides. Now I just need to find the area of ABC using our regular formula. So in order to do that, I'm going to draw the altitude from B to AC, and we can drag that down a little further like that. So we have that this is 90 degrees because it's the altitude, and since it's isosceles, it's going to cut AC in half, so we have 6 as AH and HC. Now to find BH, I can just use Pythagorean Theorem. I have 10 squared equals 6 squared plus BH squared. Now you're just going to find that BH is equal to, if you really break this down, 10 is 5 times 2, 6 is 3 times 2. That means you have a 3, 4, 5 triangle, so your last side has to be 4 times 2, which is 8. Or you can just calculate it the regular way. So, now I can find the area, because area is also just 1/2 your base, which is 12, times your height, which is 8. Breaking that down, we get that this becomes, well, half of 12 is 6. 6 times 8 gets you 48. Now, plugging it into the formula over here, we have that 48 equals R times the semiperimeter. And that's just half of the regular perimeter. So we have half of 10 plus 10 plus 12. We can simplify that fairly easily. Well, 10 and 10 is 20, plus 12 is 32. Divided by 2 is 16. Dividing 16 on both sides, we are going to find that r is equal to 3. And that is our Inradius. So again, if you're trying to solve these problems, think about what you're trying to find, and then look back at the lessons and try to think about the different formulas or theorems that we discovered and how they might help you find it. So, from here, now we have to find the circumradius. So, how can we go about finding that? Well, the circumradius is the you can think of it as the circle that passes through all the vertices. So the way we found that is with the perpendicular bisectors. So the perpendicular bisector of BC, AC, and AB. That would be the center of your circle. And then if you expand it outward, we note that it passes through all 3 of the vertices. So what I'm essentially trying to find is the radius of this circle from the point I to one of these outside points. No, not that one. What am I doing? You want to find the distance from the point I to one of the vertices. So you could say I to A, or I to B, or I to C. Now, since your circumcenter I has landed on the line BH, well, how do I know exactly that it does? Well, that's because the angle bisector, or the altitude of B to AC, since it's an isosceles triangle, cuts AC in half. So that means the perpendicular bisector of AC has to pass through B as well, because B is halfway between. It's equally distant from A and C. So I want to find the length of, I would say it's probably easiest to find the length. I want BI. BI is my circumradius. Now, how can I find that length? Well, I know BH is 8. Okay. Well, what else could I do? Well, you don't have a lot to go off of, but what you could do is, you're trying to find, there's really 3 important circumradii. BI, and then from A to I would be another. And if we think about the segment from A to I, that is the same thing as BI. So, because they're both the radius of the circle. So BI, if we were to call that like X, that means that AI would also have to be X. And let me just get rid of these lines because they're kind of making the diagram really, whoops, a little crazy looking right now. There we go. So now that I'm working with this simpler diagram, I can see that this triangle AIH is a right triangle. And, well, how does that help me out? Well, I know AI is the same thing as the circumradius, so it's the same thing as BI, which means that if I find AI, I'll have my answer. And right triangle implies Pythagorean theorem. And I know that AI is what I'm trying to find. AH is 6. But what is IH? Well, if I write out the Pythagorean Theorem right now, we have that x squared is the hypotenuse squared. Then we have 6 squared plus, now IH. IH would be this, well, I know what BH is. BH is 8. And IH is the length of BH minus BI. Well, we said that BI was our x value. It's our circumradius. So I can actually put the expression 8 minus x squared in for BI. No, I mean HI, sorry. Because if BI is x and BH is 8, then IH is 8 minus x, and we just square that. So now all I have to do is simplify. We have x squared equals 36 plus 8 minus x squared is 64 minus 18x plus x squared. Then if I subtracted x squared on both sides, they would cancel out. And I'm left with 0 over here. And 36 plus 64 is 100 minus 18x. And then if I subtract 100 on both sides, I have negative 100 equals negative 18x. Dividing by negative 18, I get that negative 100 divided by negative 18 equals x. And negative cancels out, and they're both divisible with, oh, what am I doing? It's not 18. Gee. Sorry. This is not 18. That is 16. Negative 16x. 16. I knew I was messing something up. 16. There we go. Because if you multiply this out, 8 times negative x, negative 8x, and you do that twice, 8 and 8 is 16. So, both of these are divisible with 4. So, 100 divided by 4 is 25, and 16 divided by 4 is 4. And that is your circumradius.